class. Didn't see that. Today, I myself and my assistant Brandon DC will be teaching you guys about projectile motion. I will be teaching the formulas and some examples that Brendan will be demonstrating.
A projectile is an object upon which the only force acting is gravity. There are a variety of examples of projectiles. An object dropped from rest is a projectile. An object that is thrown vertically upward is also a projectile. And an object which is thrown upward at an angle to the horizontal is also a projectile. A projectile is any object that once projected or dropped continues in motion by its own inertia and is influenced only by the downward force of gravity. By definition, a projectile has a single force that acts upon it, which is the force of gravity. If there were any other force acting upon an object, then that object would not be a projectile. Thus, the free body diagram of a projectile would show a single force acting downwards and the labeled force of gravity, which is simply F-grav. Regardless of whether a projectile is moving downwards, upwards, and rightwards, or downwards and leftwards, the free body diagram of the projectile is still as depicted. By definition, a projectile is any object upon which the only force is gravity.
Here are the formulas for projectile motion.
Thank you. So the formula for projectile motion is y equals 1/2 a t squared plus vit plus yi.
Y equals height. T equals time. A equals acceleration. Vi equals initial velocity, and yi equals initial height.
And now to the professor.
Okay, what we're going to do is look at a projectile problem, and we've simplified it so that we really only have to do a couple of things and we will always get the answer. First, what you got to realize is when a projectile is projected, it's moving horizontally with uniform motion, meaning it'll keep going at the same speed or velocity in that direction. When it comes to the vertical direction, the projectile is accelerating down just like any other object. So its acceleration is 9.8 meters per second squared down, and since I've defined up as positive, that's why I get that negative. So since I'm going to think of this projectile's motion as having a horizontal velocity and a vertical velocity, I put all the vertical information here and all the horizontal information here. In the vertical, I've got acceleration. So for these variables, which I have in the vertical, I'm going to use my big five equations. So I've got A, D vertical, V1 vertical, V2 vertical, that's the initial vertical velocity, the final vertical velocity, and I've got time. In this column over here, in the horizontal, I've got uniform motion. Since it's uniform motion, I have only three variables for my formula V equals D over T. I've got the horizontal distance, I've got the horizontal velocity, and I've got the time. All the vertical information goes here, all the horizontal information goes there. The only thing that can go from one column to another is time. These are both happening at the same time. Let's say I want them to solve for the horizontal distance. How far does this projectile go when it's launched at a certain velocity? If that's what I want, then they're going to need, because it's V equals D over T, 2. They're going to need both these to solve for the answer. So I might give them the horizontal velocity. So I might say something like 200 meters per second is the horizontal velocity. So I'll give them that. But I won't give them time because that would make it too easy. I've got one formula, V equals D over T, so if I rearrange that, in the horizontal displacement is a horizontal velocity times time. So I've given them the horizontal velocity. It would be just too easy to give them the time because you just multiply those two out and you've got the answer. So what I'll do is I'll say, well, I'll give them three things here and make them solve for time here, and then go over to this column, put it in there, and then they just have to multiply those two. So in this column, I need 3 things, because from our big 5 equations, our 5 formulas, and the video on that, you know that in order to solve for any one of these, you need 3 others. So let's look what I got. Well, the object is projected at 200 meters per second horizontally, so there is no vertical velocity. So initially, it's 0 meters per second. At this point, its velocity is all horizontal. Sure, later on it gets down to here, it does have a vertical component. But right now, it's only got a horizontal component, so there's no vertical. And now I have to give them something else, so what I might say is, well, let's say the projectile goes down 40 meters. Okay? So if it's going to go down 40 meters, I look at my sign convention, because it's very important for the vertical to use your sign convention. Well, up is positive. The ball went from here vertically down, so this would be negative 40 meters. So look at my plan. I've got 3 of these. I can certainly solve for time. I take the time, it's the one that can cross from the vertical column to the horizontal. I bring the time over here, I can solve for this because I got that one equation, d horizontal is v horizontal times time. So how am I going to solve for this time? Well, you probably know v1t plus 1/2 at squared. I'm going to plug into that. Negative 40 equals 0 times time is going to be 0 plus 1/2 negative 9.8 t squared. I solve for t. I'm not going to waste the time to do that because I've already worked it out over here. 2.9 seconds. I now know the time in the vertical is 2.9 seconds, so therefore the time here, 2.9 seconds. In the horizontal column, I've got my 2 variables, so I can plug in here. Horizontal distance is 200 times 2.9. The horizontal distance is 580 meters. Now, if I wanted to come up with a different question, I might decide, this time I want to find the vertical distance. I want to find out how far down it landed if it went a certain horizontal distance. So I might say, okay, they've got this because they know it's always 9.8. I want them to find this, so they need 3 things. 1, I might give them this. And then I'm not going to make it too easy by giving them time. I'll give them these 2. They'll solve for time, bring it over to this column, and use it to solve for what they're looking for.